Good morning. So today, Unit 10, Classwork 12, Tangents and Secant Length. Last time we had intersecting secants or chords inside a circle. Today we're going to talk about when a tangent and a secant, two secants or two tangents intersect on the outside of the circle, how we figure out what those lengths are. So for prior knowledge, if a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. So if we know PQ is tangent to the circle at point P, then we know we've got a right angle here. And if PQ is 8, and we know all of CQ is 15, and we wanted to find CP, how would we find that? Of course, we would use our Pythagorean theorem. So CP is terrible. CP is 15 squared minus 8 squared. And so we can plug it in our magic calculator and get a good rounded approximate 12.7. All right, so let's go learn two more rules about these lengths. Here we go. If two secant segments share the same endpoint outside the circle, so two secant segments, same endpoint outside the circle, then the product of the length of one secant and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. What am I talking about? So what I'm talking about here is FD is the whole length of a secant. And if I go FD times FE, that external part, that's going to equal, can you hear my cat? After this. That's going to equal FH, the whole length of the other secant, times FG. So let's plug in those numbers. We know that from D to F or F to D is 17 and FE is 3. We know that G to F is 6. We don't know FH. So we're just going to plug that in. 17 times 3 equals 6 times 51 equals 6x. X equals 8.5, which means then the whole length FH equals 8.5. So let's practice. Make sure you add together. 6 times 16 equals 8 times x plus 8. The one thing we might forget to do is distribute. So remember when we have these, when you have to add those segments and x is involved, you might have to distribute. 6 times 16 is 96. 96 equals 8 x plus 64, subtracting 64 from both sides, dividing by 8, x equals this whole length is 9, this whole length is x plus 9. So we have x times x plus 9 equals 4 times 9. X squared plus 9x equals 36. We need to get that 36 over to the other side. X squared plus 9x minus 36 equals 0. This will be about as hard as it gets on the quiz on next Friday, where you have to do some factoring. We need the two numbers that multiply together to give us negative 36, but add together to give us 9. Well, let's go through the factors of 36. 1 and 36, 2 and 18, 3 and 12. Oh, look, 3 and 12. I can get 9 out of 3 and 12. How do I get 9 out of 3 and 12? Well, plus 12 minus 3. Negative 3 times 12 is negative 36. 12 minus 3 is 9. So when we do our math, we want x plus 12 equals 0 and x minus 3 equals 0. Well, if I subtract in the first equation 12 from both sides, I'm going to get x equals a negative 12. And in the second equation, I'm going to get x equals 3. Looking up at the diagram, can you have a negative length? No. This is our answer. X equals 3. All right, the second. If a secant and a tangent share an endpoint outside the circle, so a secant and a tangent endpoint outside the circle, it's a little different. In this case, I can take the secant, the whole secant is RT. So it says, then the product of the length of the secant segment and the length of its external segment, RS, equals the square of the length of the tangent, RQ squared. So let's plug in. RT is 25. RS is 5. And we want to find QR. We'll put an X there. So 5 times 25 equals X squared. So I took the square root of both sides, I get X. And 25, you know, is 5 squared. So in this case, X equals 5 radical 5. But you can plug that into your calculator and get an approximate RQ equals 11.2 if we were to round to the nearest unit. 10th unit, sorry. All right, let's practice these. When I do this, I always find it easier to start with the side that I'm going to square, but you can do however you like, but I like 8 squared equals X times, well, this whole length, X plus 12. So 64 4 equals x squared plus 12x. We're going to move that 64 over. So we're going to have x squared plus 12x minus 64 equals 0. And we think of the factors of 64. You can do like I did in this previous problem and just start writing out the factors of 64. But we want the two that multiply together to give us negative 64, but add together to give us 12 simultaneously. One of them is 16, the other is negative 4. Negative 4 times 16 is negative 64. Negative 4 plus 16 is 12. So looking at these together, I have x minus 4 equals 0 or x plus 16 equals 0. We want the one where x equals positive 4. This problem is honors, not required by you, but I have the worked out solution on the answer key that I'll distribute later today. Here we go. We want to practice these problems together. So I know from last time that the chords, we can make similar circles and set up proportions because of the reflection in the shared arc, or I can just use the theorem and go, well, that's x times 15. This 15 is on the same chord as x, 10 times 18. So I've got 15x equals 180. We're going to have x equals 12. For the next one, we've got two secants. So we're going to have 12 times x, and we're going to have 15 times 40. X equals 50. 6 times 16. Remember, we got to add those together. And 8 times x plus 8. X equals 4. Remember to distribute. Next one, 4 squared equals 2 times 2 plus x. X equals 6. Next one, x squared equals 4 times, what's 4 plus 5? 9. 4 times 9 is 36. Starts wandering. X equals 6. And the final one, x times x plus 3 is going to equal 2 squared. You're going to have to factor this out. You're going to get x plus 4 equals x minus 1. And looking at that, you should be able to tell the one we want is x equal to 1. Make sure you read the email carefully today. I'm going to put a picture of the rule, all 3 rules in that we're going to use on the quiz next week.